typed, in so much that you can put anything inside of a collection. At first glance, that might seem great, but what if I wanted to actually then print out a list of all of the cars, makes, and models? So let me start by, at the very bottom here, type console.readline so we can get through that formality, and then I'm going to just do a for each. And what am I going to work with here? Let's just say I'm going to work for each car in my array list, all right? And then I might go console.writeLine, and let's just go car.make, like so, all right? And print that to screen, and let's run the application, and we will get an exception whenever we hit the third item in our array list. Notice that it has printed the first two to screen, but when we get to the book, it says that there's an invalid cast exception. In other words, we could not convert a car, or rather a book, which was the third item in the array list, into a car. So when we get to this spot in our as we're iterating through each of the items in our array list, we're going to hit a problem here. And the fundamental problem is that we allowed our collection to store something other than cars. So we cannot work with these collections in a strongly typed fashion. Now what I can do, and one of the neat features here, is that I can actually remove that item prior to going into that for each list, and we should just be able to execute the application without problem. All right, so that is at least one of the good benefits there. But unfortunately, the downsides outweigh the benefits, and so let's go ahead and take a look at the newer style collections. The first I said was that we were going to look at a list, and more correctly we're going to look at something called a generic list. So often you'll see it referred to as list of T, like so, all right? And so that of T in the term generic might require a little bit of explanation. When .NET was first released, the first set of collections allow you to put anything you wanted into them, like we saw here just a moment ago. Now, it might make sense in some contexts, but typically it doesn't, and it leads to potential errors like you saw. Now, at some point then, C# introduced the notion of generics. And specifically for our purposes, they released a series of generic collections. And so a collection is essentially generic, but it requires that you make it specific by giving it the data type that should be allowed inside of that collection. So we have a generic list, but we're going to make it a specific list to cars so that we can't even add a book to that collection. So let's attempt to do this one more time. This time we're going to go list, and notice that I'm using angle brackets, and in between the angle brackets I'm going to say what data type I want to use. In this case I want to use the car data type. So list of car called myList equals new list of car, like so. And at this point, we can go ahead and add car 1 just fine. We can add car list to my list. We can add car 2 just fine. But what happens when we attempt to add the book into our list? Well, at the point when we attempt to add the book to the list, we get an exception. We hover over and it says it cannot convert a book to a car. All right, and that makes a little bit more sense. It is specific to a car data type, so we cannot add a book to that list. But from this point on, we can work with it now with some confidence. So each car in my list. And we can just do car.model, like so. And we would get what we would expect here. Great. A list of our car models. Okay? So that's one of the big benefits of working with a generic type, is that it allows us to work with a specific data type and only allow those types into our collection. So this is probably the most popular of all of the collections available, but I'm going to show you one additional collection called a dictionary. And a dictionary is similar to, like, think of Webster's dictionary, where you have a word and you look it up in alphabetical order and find the word that you want a definition of. And then once you find the word, you can look to its right and it will have the definition. So there is a key, which is the word itself that we want to look up, and then there is the definition next to it. So there are two components to each entry in a dictionary. There's the key and then the value itself. And so typically when you see a generic dictionary mentioned, it's going to be kind of listed like this: dictionary of T key, T value. So in this case, what we'll do is specify the data type of the key. This allows us to find one specific item by the key. Now the key should be something that is unique to every entry in the dictionary. In the case of people, there might be some identifier. It could be a customer ID in your system. It could be a social security number if you're in the United States. But something that uniquely identifies one entity inside of that dictionary. And then the value can be of any data type. In the case of, again, a customer, you might have the customer ID being the key, but the customer object itself is the value that we actually want to get access to. Now in our case, this seems a little bit weak because our car class only has make and model. And we know that we could have multiple cars that have the exact same make and model. They may have different colors, they might have been created in different years, but you can have multiple cars in the car lot that have the exact same make and model. So neither of these are good candidates for keys, but there is something called a vehicle identification number. So let's go prop string, and let's call this VIN, VIN, that will differentiate every car in the world that's been created. So what I'll do is come back up here to the definition and go car1 VIN, and I'm just going to use a very short VIN number. I think they're typically like 18 or 24 characters long or something like that. I'm not exactly sure, but this should uniquely identify every car in the world, especially every car on our car lot. So now what I can do is create a dictionary of my cars by starting off and saying something like dictionary, and then we're going to give it the two data types. The VIN will be of type string, and then the actual value will be of type car. And we're going to call this my dictionary equals new dictionary of string car. Notice that IntelliSense helped me out by essentially giving me a lot of that, and I can just hit the semicolon at the end of the line for it to type out that entire phrase. And now that I have this, what I can do is go my dictionary dot add, and it'll do car1 dot VIN and pass in car as the actual value. So the car1 VIN again is our key into the actual car1 itself. Okay. And likewise, we'll go add car2 dot VIN and car2. All right. And so at this point here, if I were to attempt to find a given item, so console dot our right line, and I need to find a specific car on my car lot, I can allow a user to type in the VIN number and I can look it up in the dictionary quite easily. So say for example I want to do my dictionary dot, and then there's a number of different ways to go about this. I think probably one of the easiest ways, actually, let's go back and not use the dot. And here I'm actually going to use the key itself. So we'll call this B2. And then now we can reference a specific item in the dictionary of type car, so we can get the make, for example, and print that out to screen, like so. All right, we were able to find the geo that way. All right. All right. So hopefully that makes sense. Let's continue on. If you recall, when we originally were looking at, and let me comment all this out. we were looking at arrays. I said there's some interesting things you can do to initialize an array with values like we see here. Here we're creating a string of an array of strings called names, and to initialize it I give it a collection of names that are comma delimited. And so now I have an array that has 4 elements in it, and it's already been initialized with the values. You can do the same thing with the objects to initialize objects at the point of instantiation. So to do that, we'll use an object initialization syntax. In fact, let's go ahead and just to prove this all works, let's comment out everything we have up here as well. And get rid of the cars in the book. And we'll come down here and go car1 equals new car, and then notice what I do. I use that same syntax, the curly braces. And inside of here what I can do is actually define all the values. So make equals, let's just dream large here and go make, and the model would be a 750, and we'll make it an LI, and then we'll also give it a vehicle information of C3. Alright, like so. So now I've done actually 3 things in one line of code. I create a new variable called car, I create a new instance of car in the computer's memory, and now I'm getting access to that address in memory by using the car1 label, the variable name. And then I go ahead and populate the properties of the car object at the moment that I create that new instance by using this object initializer syntax. All right. Some people don't like this. It looks like it might be doing too much in one line of code, but I think you'll find that if you ever do need to hard code examples like I do frequently, that this shortened syntax actually saves you several lines of code, and it's just fine. It's valid code. All right, so let's go ahead and while we're working here, let's go ahead and create a Toyota. We'll set the model equal to a 4Runner, and we'll give that a VIN of D4. All right, like so. Okay, and so now we can work with the cars just like we did before. But in and of itself, this might not be so interesting. But this is the object initializer syntax, and we can take this one step further when it comes to working with collections. So we can use collection initializer syntax. And I want to point out one other thing, that we didn't have to use a constructor to make this work like we looked at before. That we're able to, regardless of the constructor, go ahead and set these attributes just like we use the syntax there. All right, but let's now talk about a collection initializer, which can look a little hairy, but it's essentially the same thing. We're just taking it to the next level here. So in this particular case, let's go ahead and create a list of car called myList equals a new list of car. All right, now at this point what I can do, and notice that I put this on separate lines here. I typically might keep this on the same line just for my own sanity here. And now inside of this new empty list of cars, I can create a series of car objects like so. In fact, what I can do at this point then is use an object initializer inside of that. So here we'll go, make equals Oldsmobile, and then we'll set the model equal to Cutlass Supreme. And then the VIN number, we'll set that equal to E5, also, comma, and then we'll create another new car to add to this list of cars, and we'll set its object initializer, setting its make equal to Nissan, and its model equal to an Altima, and then finally its VIN will equal F6, something like that. Okay. And now what I've done all in one line of code essentially is I've created a collection and I've added 2 objects, and in each of those objects I went ahead and already initialized all of their property values. All right. Whew. So there's a lot going on there in just that one line of code. Great. So at any rate, just wanted to recap the things that we talked about in this lesson. First of all, we talked about the difference between arrays and collections, and I promised that there will be a more obvious set of features that are available to collections, which we'll learn about in the next video. We talked about the old style collections versus the new generic collections, and we said generic collections are superior because they allow us to make sure that we're only adding types, specific types to our collection. So we make a generic collection specific by passing in the data type that should be allowed to be referenced inside of that collection. Okay. Then we looked at object initializers, just a shorthand syntax for initializing the properties of a new instance of an object. And then finally taking that one step further within a collection initializer, where not only are we creating a new collection, but then initializing it with new instances of the car collection. In both of those cases, then we are using object initializers. So we can do it all on one line of code. Now, honestly, unless you're building a lot of example code like I do, you may not see this as often unless you are creating some hard-coded objects for use within your application. But I wanted you to be aware of that syntax nonetheless, because we're going to use it again in the next lesson. And we'll see you there. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we're going to look at LINQ, the language integrated query syntax that was introduced some years ago to provide a way to filter, sort, and perform other aggregate operations on collections of our data types. And so we'll demonstrate two different styles of LINQ syntax. There's a query syntax that will resemble the structured query language SQL for querying databases. So if you're already familiar with SQL, this will at least feel familiar. Then there's also a method syntax, which might feel more familiar to C# developers. However, there is one little strange nomenclature thingy that we got to figure out, okay? But I think it's pretty easy. I think I have a good way of explaining it to you, and hopefully you'll understand what it's trying to do there. But what I'd recommend is you find the code for this lesson. There should be a before and after folder, and you want to copy the code in the before folder into your projects directory, and then open it up, and you'll be where I'm at right now in the Understanding LINQ project. You can see that I merely created a car class, and then I also have here a collection initialized class filled with cars, filled with attributes that we'll be able to search and sort on, and that'll give us something to work with here. All right, so what I want to do to begin with is to kind of show you a comparison between LINQ's query syntax and then LINQ's method syntax to do the exact same thing. And you'll see the obvious difference, and we'll talk about the ways in which they're different. But let's begin with a query where we want to find all BMWs in this list of cars called My Cars. So it's as easy as this, and we'll talk about the var keyword here in just a moment. But BMWs equals from car in cars, whoops, from car in My Cars, where car.make is equal to BMW select car. All right. And so now let's come down here and print all those guys out. So let's go to console.write line. And let's provide the vehicle information number. So let's do 0 and 1. So we'll go, actually, let's do this. Let's go for each, tab, var car in BMWs, console.write line, and then we'll go car.model and car.vin. All right, and let's Let's go ahead and add some of our replacement characters in there. All right, now let's go ahead and run the application. And we see that we get 3 cars that have been returned. So of all of the cars, I think there's 5 or 6, 3 of them with those VINs, A1, C3, and E5 are BMWs. And if you take a look at the data, that would be correct. So very quick, concise way of finding only those cars that match that criteria. All right, what if we wanted to add additional criteria? So say, for example, we wanted to also see where the car's year equals 2010. We could do that and rerun the application, and now we see that it just finds one of the BMWs was created in 2010. It is this last one, the 555i. All right. So that is the language integrated query syntax, the query syntax of LINQ. Let's go ahead and comment that out and compare that to the method syntax. And so here we'll go var BMWs equals mycars dot where. All right, so this will give us all the BMWs. So let's go ahead and run that. And it gives us the same 3 that we got before. Now what if we wanted to also find only those where the year is equal to 2010? Then we would do that. Okay, and so you can see we found just that E5, that last one. All right, so this might take a little explanation here. For the moment, let's just ignore this last part. We'll talk about that in a moment. But what you see here, in fact, the whole thing in between the opening and closing parentheses is called a lambda expression. And you can think of it as a mini method. Essentially, what will happen is you say given P, so given an instance of the collection, only return back to me those instances of car where the make is equal to BMW. See how easy that is? Again, just a mini method. You can kind of think of this as like the input parameter, and then this is just some condition, and when it's true, then return that instance and add it into this little collection over here. So now that we have a subset of all of the available cars on our car lot. Furthermore, I just added the logical AND operator and said, and make sure also that it was in 2010. Okay, well that filters out 2 of them. So again, mini method, lambda expressions are just mini methods. So for any given item in the collection, it has to match that criteria, and if it does, then we can add it to this little subset collection over here that I'm calling BMWs. All right. So the var keyword, it has a very different connotation in C# than it does in other programming languages. So here I would ask that you forget what you know about var from maybe JavaScript or Visual Basic or some other programming language. It does not mean the same thing. In this case, the var keyword says that we're going to let the compiler figure out what the correct data type is. I'm not even sure what gets returned from this little query that we do here. If you were to hover your mouse cursor over the where, you can see that it's going to return back an IEnumerable of car. What's that? Not entirely sure. Doesn't really matter. I don't care what it is. I know that it is a collection of cars. And kind of to prove this point, we'll talk about this in just a moment, a little bit later, where the var keyword can really come in handy because we truly don't know what it is that's being created by our LINQ queries. Okay, so again, the var keyword, it's still strongly typed. We're just going to let the compiler figure out what the type is at the point when the code is compiled. All right? All right, so let's move on and let's take a look at a few other examples. So I may want to find a list, an ordered list of cars. So I might go ordered cars equals from car in my cars, order by car.year descending select car. All right, so that's how I would take all of my cars and order them in descending order by their year. And then let's just change this from BMW. let's put this to ordered cars, like so. And this might help if we actually saw the year itself. So I'll add in car.year as well. And let's go ahead and run the application. And so you can see it starts at 2010 and in descending order works its way back to 2008. Awesome. All right, so that same query, if we were to do it in using the method syntax instead of the query syntax, it would look something like this. So var ordered cars equals my cars dot order by descending. So given each item in the collection, only return those or actually order them by the year, like so. And we should see the same grouping, and we do. Starts at 2010 and works its way back to 2008. Awesome. So again, in my opinion, this is more concise. The only conceptual hurdle you got to jump over is just make sure you understand what a lambda expression is. In this particular case, it's not a filter. We're just saying, given each item in our collection, we want to order by this particular property, the year, all right, and then add that ordered item to our collection of our new collection of cars over here. Okay. Now there's a lot of interesting things that we can do, and I'm only going to work with the method syntax from this point on. So the first we might do something like this. For example, if we wanted to find just the first item, so let's go ahead and grab this, and maybe we want to find the first item where the make is equal to BMW, like so. So this will give us the first car, the first BMW car in the list that it finds. All right. So let's go ahead and console. In fact, let's change the name of this to first BMW. So console.writeLine. First BMW dot, let's go, just the VIN number should be sufficient. Let's run that. All right, so we can find that the first BMW in the list was A1. Or we can do the first BMW, and we can actually start by ordering by descending, given the year. So you can see I'm chaining these together. We've talked about method chaining before. This will return a collection of cars, and then this will return a single car in that collection. And then we'll print that single item's VIN out to a window, in this case E5. So the list is first sorted, and then we grab the first one that matches our criteria of BMW, okay? So that's how we can use first. I'm going to comment that out. We can also do something like this, console.writeLine, and inside of here, let's go my cars dot true for all, and say the year is greater than 2012. And need one more right there. So is it true that all the cars in my car lot are, that every one of them is greater than 2012? That would be false, all right? Well then how about, are they all greater than at least 2009? All right, that's still false because we have at least one that was created in 2008. If we were to change this to 2007, are they all at least greater than 2007? True. All right. So that's true for all. Very helpful in order to aggregate and look across all of them and see, is this true for all the items in my list? We can also even do something interesting like this. Instead of doing this for each statement, where it's essentially, at least 2, if not 4 lines of code, we can create a for each like so. My cars dot for each, And then inside of here, for every item, let's just do a console.writeLine. And in here, I can do p dot the VIN and p dot the sticker price. All right. And so let's go ahead and do that.